Okay, now we're going to take a look at some independent problems, independent outcomes. So remember, independent are events that don't affect one another either way. They are independent from one another. Okay. This rule is for independent items only. Now, this rule only works for independent items, so if you're given these individual probabilities and then the probability of two events happening at the same time, that and the intersection, if you're given all those numbers, you can see if it satisfies this equation, and if it does, then they are independent, and if it doesn't, then they're not independent. Or you could be given a problem where you're told the events are independent, and then this relationship is true. And this relationship is basically when two events are independent, the probability of both events happening at the same time, that intersection, the and, is going to be the product of their two individual probabilities. So let's take a look at this example problem I have written out here. The example will happen in a moment. This pretty much just says what I just said out loud. When two events are independent, the probability of them happening together is the product, answer from multiplication, of their individual probabilities. So there's a group of 200 kids. Event A is going to be that a child randomly picked is a male, and event B is the probability of a child being randomly picked having brown hair. Now, I tell you in the context of the problem, the events are independent. That means if we want to calculate the events happening at the same time, that probability, we can multiply the individual probabilities of either of these happening. All right, back to the problem. So event A, a child is a male, 42%. So 42% of the kids there are male. The chance of randomly picking someone with brown hair is 50%. Now, these events are independent. That means that the number of people who are male and the number of people who have brown hair, it doesn't actually matter. 50% of all the females have brown hair, 50% of all the males have brown hair. So they're really independent. It doesn't, the probability of picking brown hair doesn't depend on picking a male or a female, is another way of thinking of it. So, can we just crank it out real quick? So the probability of picking a male with brown hair, that would be the probability of picking from event A and B at the same time, and intersection. So it is the product of their individual probabilities. 0.42 times 0.5 is 0.21, or 21%. There's a 21% chance of randomly picking from these 200 kids and picking somebody that is both male with brown hair. Now, let's apply that other rule about individual probabilities to a large set here as well to answer this extended question. How many males with brown hair are in the group? Well, if we have a 21% chance, or 0.21 as a decimal, of picking a male with brown hair, and there are 200 students altogether, you can simply multiply the number total times the individual percent, and 42 of these 200 students are males with brown hair.